In reviewing factoring, we're looking at all of the different types of factoring from grade 11 and from grade 10. And then we're adding for grade 12 for advanced functions, the new type of factoring. And we're going to be introducing the formula sum and difference of cubes. So the first thing you want to do when you're looking at a polynomial is to ask yourself, is there a common factor that I can pull out of each term? So if I have this expanded form and I see something that I can pull out, I want to do that first. If not, then I want to proceed directly to the next question. After you pull out your common factor, you're also going to move on to how many terms are there. Well, if it's a difference of squares, or it turns out now we'll be introducing the difference of cubes, there's going to be 2 terms. If you're looking at a trinomial, 3 terms, it could be a simple factoring situation if your coefficient in front of x squared is 1, or if your coefficient in front of x squared is not a 1, it's going to be a harder factoring, or you might have heard it called complex factoring situation. And then if you have 4 or more terms, you're probably looking at something like factoring by grouping, which is really just a special case of common factoring. So let's look at some examples. If I have something like 2x squared plus 4x, you'll hopefully notice that I have a greatest common factor that I can pull out of both of those terms. I can pull out a 2 and an x, and I'm left with an x plus 2. And then if I check what's left over, the 2 terms there in the bracket, x plus 2 is as factored as we can go, so we're done with that one. Number 2 is also a type of common factoring, except for now we have 2 groups of terms, and we have a binomial common factor of a plus b that we can pull out. So if I pull a plus b out of both of those groups, what would be left over would be an x minus 5. Step 3 is just taking the factoring by grouping a step further. Still, we're just common factoring. So we're looking at 2 groups of 2 here. In the first group, I can pull out an x, and I'm left with x plus 2. And in the second group, so terms 3 and 4, I notice I can pull out a negative 2, and x squared is the lowest power because I have an x cubed and an x squared. And what would be left over would be x plus 2. It was really important that I picked the minus 2x squared to pull out there, not positive 2x squared, or my signs would not have matched up inside my bracket. Now I can look at both of these groups and notice that my binomial common factor is x plus 2, and I'm left with x minus 2x squared. You could stop there, but you wouldn't get full marks because you would have missed another additional common factor. You'll notice that I can pull a single x out of both of these terms, and I'm going to bring that out front. So I have x now out front, and I'm left with 1 minus 2x inside my bracket. So that's an example where I have to pull out a common factor at the end in order for it to be fully common factored. Question 4 has 2 terms. So hopefully after you've checked for a common factor, you're thinking that that should be a difference of squares because we have a minus sign in between, a difference, and we have some nice perfect squares. So what you're going to do is you're going to take the square root of x squared. X times x is x squared. So I have an x at the beginning of each bracket. And then the square root of 9 is 3. And the square root of y squared is y. So we're going to have a 3y and a 3y is the second term in each bracket. And those terms are going to be identical in both brackets. If I put a plus here and a minus here, that's going to make it so that the middle terms cancel out. That's why I only have 2 terms. So let's just double check. X times x is x squared. 3y times negative 3y is negative 9y squared. And then the magic with difference of squares happens when we have x times negative 3y is negative 3xy. And we have plus 3xy in the middle, and so that makes 0. In number 5, you notice that there are 3 terms. So it is a trinomial. We check the coefficient in front of the x squared is a 1. So if this is going to be a simple factoring situation. And with simple factoring, what you want to do is you want to look for 2 numbers that multiply to that last term and add to the middle term's coefficient. So factors of 12 that I could use 3 and 4, and they would both be negative because I'm trying to multiply to a positive number and add to a negative number in the middle. I could have also picked -6 and -2, or -12 and negative 1. Only one of those sets is going to work though, because if I pick x minus 3 and x minus 4, negative 3 plus negative 4 gives me the negative 7 I'm looking for in the middle. So they have to add to the middle term's coefficient as well. And we can always expand to check. X times x is x squared. The last terms, negative 3 times negative 4, that gives me positive 12. And then the outer terms give me negative 4x. The inner terms give me negative 3x, and that gives me back negative 7x when I collect like terms. The last example is an example of harder factoring because we do have this coefficient in front of the x squared that's not a 1. There's a couple different methods that you might have learned. It doesn't matter, you pick whatever works for you. So I'm going to go over both. The first one I'm going to talk about is crossover. So with crossover method, basically what you do is you look at factors of negative 15, just like you did with simple factoring, but you also need to look at factors that are going to multiply to 8x squared. So we're just going to start with two factors. 8x squared could be 4x times 2x. And they're always going to be positive if the first term is positive as well. We're just going to play around with the second factor's signs. Negative 15, I'm going to start with negative 5 and positive 3. Crossover gets its name because we're going to multiply across. So 4x times 3 gives me 12x, and 2x times negative 5 gives me negative 10x. That does not add to negative 14. That gives us positive 2x, so that doesn't work. Now, before I throw out those factors completely, I need to switch these around because they could just be paired up incorrectly. So now I'm going to do this instead. 4x times negative 5 is negative 20x, and 2x times 3 is plus 6x, and now I'm in luck because when I add them up, I end up with negative 14x, which is the middle term. So then my brackets are going to look like this. 4x plus 3 is my first bracket, and 2x minus 5 is my second bracket. And with crossover, you don't have a lot of work to show, but you do need to be really confident in those multiplication tables so that you can see and easily work with the factors. Decomposition works every time, but it involves a little bit more work. So with decomposition, what you're doing is you're trying to find two numbers that multiply to the product of 8 times negative 15. So when you multiply those, you get negative 120. And then they have to add to negative 14x. So I'm thinking about breaking down negative 14x as negative 12. Nope, that's not going to work. Negative 20x and plus 6x, because negative 20x times 6x is going to give me the negative 120 I'm looking for. Negative 20 times 6 is negative 120. And negative 20x plus 6x gives me negative 14x in the middle. So that's good. So what we're going to do is we're just going to rewrite this. We're not changing anything. We're just breaking down negative 14x as negative 20x plus 6x minus 15. So the only change I did here was I just separated this out. It's kind of expanded out to two separate terms, but it's equal to the line before. And the reason I did that is so that I can now common factor. So if I pull an x and a 2, well, I guess actually an x and a 4 out of the first set of terms, I end up with 4x times 2x minus, let's see here, 5, which I just noticed up here. I made a mistake. This was 2x minus 5, not 2x plus 3. And then from the second group of terms, the 6x and the minus 15, I can pull out a plus, let's see, a 3 could come out of there. So I'm left with 2x minus 5. And then factoring by grouping, I've got those common factors of 2x minus 5. And I'm left with 4x plus 3.